Hello everyone. So today we'll start the discussion with this problem. This problem is of double limit and double summation. So how we break it down, let's try to understand. So first you observe that here I have this expression given in terms of m and k and r. Now k is running from 1 and going up to mr. It means when we are considering this expression with respect to k, the m and r considered to be the constant. And for that sum, because k goes from m to r, I can assume that the m is approaching towards infinity. So here r is constant and n is constant, m is not constant. So what I'm going to do is, for this summation I am going to take m first as variable which is approaching towards infinity. It means I'm swapping this limit. I'm just inserting this limit m tends to infinity to evaluate this first inner sum, and then whatever result will come, again I will apply the limit onto that. So what I'm calling is the S inner or S in or S, that's is sum or whatever. Let's say the sum inner is this one, limit m approaches infinity and summation k goes from 1 to m r m n squared divided by m square n squared plus k squared into n squared plus r squared. Now we think carefully and we understand that when k is running from 1 through mr and m is approaching towards infinity, so the other things, that is n and r, I can assume as a constant. So I'm dividing this thing by m square and I'm keeping this limit aside because I have to work on that ahead. This is, I'm dividing with m squared. So if I divide by m square, I can write in this way, n squared, and this will turn into n squared plus k by m the whole square and into 1 by m. Because notice what I have done, that this term I'm dividing with m square and this term I'm dividing by m square. So this m by m square become 1 by m, which I have written here in the front, and this is going to be n square by k by m the whole square, and one extra term I am left with here, that is 1 by n square plus r square. Now try to visualize the whole scenario, that when k goes from 1 to mr and this m is in the denominator, so it's acting like n because that m is approaching towards infinity. So this is going to be a function of x when I replace k by m with x, and this 1 by m is the place value of 1 by n when we try to transform the sum of limit into the definite integration. And this 1 by n plus r square is not a disturbing element, so we can take them out with n square also. So let me just take it out, then it will be more clear. So I'm taking n squared divided by n squared plus r square, and we are left with limit m approaches infinity, summation k goes from 1 to mr, and this is going to be 1 by n squared, and this is k by m the whole square and into 1 by m. So I usually, you see this 1 by m in the front here, so I have written in the last, but it doesn't matter, or let me write it just to tally with the same thing. So now we understand that this 1 by m can be written as dx, then limit m tends to infinity, this k by m can be written as x. But there's one thing, how do we change this limit? So the idea is that we are going to turn this whole thing into a to b fx dx. So what is a, by the way? So a we find actually when limit here m tends to infinity, the lower value, this 1 by m, so that will give you 0. And how do we find the b, upper bound? Limit again m tends to infinity, the upper bound mr by the m, so that will cancel and r is considered as constant, so that will become r. It means our integration will be, means entire thing will be like this, n square by n square plus r square, and this will turn into integration 0 to r, and this is 1 by 1 plus x squared and dx, because sorry, n square plus x square dx, not 1 plus x square. There was n sitting over there, so it will become n square plus x square. Now this is not a hard thing to understand, that what will be the integration. Let me just take it down. This will not be the hard thing to understand, that what will be the integration of this. So this is going to be n squared by n squared plus r square as it is, and this is going to be tan inverse x by n with 1 by n in front, and the limit is 0 to r. So further we evaluate the limit, the bounds, so that will give you n squared divided by n squared plus r squared, and 1 by n I could cancel also, so that will give you tan inverse r by n. Here n and n will get cancelled, so let me erase it. So that will give you directly n by n square plus r square tan inverse r over n. So this we got the inner s. Now we are left with to see what we have covered, that this sum is already covered and this limit is already covered. So we are left with the limit n approaches infinity and summation r goes from 1 to n. So what we write here, that the final sum s, I am going to write is limit n approaches infinity and summation r goes from 1 to n. So you can see that now its summation is going towards 1 to infinity, because n is approaching towards infinity, so entire sum will approach towards infinity, means not sum approach towards infinity, the r is running through 1 to infinity. Now this can be written as n by n square plus r square, I'm just copying first, and tan inverse r by n. And there's no such brainy thing here, because you have tackled this kind of situation many times in the practice. So this is already a function of r by n. Now I have to turn this into r by n, so of course I will divide by n squared, because I need 1 by n, one extra term, so that I can replace that with dx. So this is going to be r goes from 1 to n, 1 by n, and that is 1 plus r by n squared and tan inverse r by n. So now it's not difficult. You can understand that when r goes from 1 to n, the limit will turn to 0 to 1. So 0 to 1, and 1 by n we are replacing with dx, and this is whole thing is tan inverse x by 1 plus x squared dx. Is already easy task now. The tan inverse x has already derivative given there, so I can directly write, and by changing the limit also we can write like 0 to pi by 4, and this is going to be t dt. So this is t square by 2 from 0 to pi by 4. Therefore answer should be pi square by 16 to the 32, and at 0 this is 0, so my answer should be pi square by 32, which is in the option, so the option B is the correct one. Let's move to the next question. Okay, so this question says that V and W be distinct randomly chosen roots of the equation z to the power 1997 minus 1 is equal to 0. Find the probability of this is lesser than equal to that thing. Is again an AIME question. I don't know why they are not creating their own question. They are just copying from here and there. Anyway, so let's see. This is of course the roots of unity. So z to the power 997 is equal to 1, and I can write z as what? 1 to the power, so you can write directly e to the power I 2k pi by 1997, and k runs from 0 and goes up to 1996. This is not so difficult. Now, what is the meaning of this mod of v plus w? If you understand the way I am understanding, this mod of v plus u is in fact asking the resultant of the two vectors, two complex vectors. So let's find this way. This I can write mod of v plus w whole square is what? Mod of v squared mod of w squared plus 2 mod v mod w cosine of theta. And what is cosine of theta? The cosine of theta means, what is theta by the way? Theta is the angle between u and v, v and w, the two vectors v and w. It means I can say that this, if I have the argument of the v is theta 1, let's say the argument of v is 1 theta I or theta k1 we can say, let's say, then argument of w is theta k2, that theta represents the difference between them. So theta is theta k1 minus theta k2. Now you notice that each of them has the magnitude 1, means each vector has magnitude 1, or each complex number has magnitude 1 because it's a unit vector. So this can be written as 1 plus 1 plus 2 cos theta. And you know this identity we have dealt with many times, so 2 times 1 plus cos theta, which is nothing but 4 times cos squared theta by 2. Now we take the square root both sides, so v plus w mod can be written as 2 times, and what is this? Is going to be cos of theta by 2. In fact, if I believe why they have given this way, there is some kind of a interesting thing is that even if you don't do that, I just realized it, so I'm going to avoid this thing. I'm going to do in a different way. So let's see here. This is okay, we can do from here, but why not we can think that this is already have v plus w mod squared is 2 plus 2 cos theta. And this has the same structure, 2 plus something. So why not we can compare this thing. So I have v plus w mod, I can write square root of 2 plus 2 cos theta. And notice that the v plus w mod is greater than this. But this v plus w mod, means mod of v plus w, is equal to that. It means whatever equal to mod of v plus w, it should be also greater than 2 plus root 3. So what you can write is 2 plus 2 cos theta square root should be greater than 2 plus root 3 square root. And now you can compare easily and you can get this thing that the cos theta is greater than root 3 by 2. It means, and root 3 by 2 is somewhere here, and I need is greater than this, and this is negative pi by 6, this is pi by 6, at which it will achieve root 2. It means whenever the cos theta is greater than root 3 by 2, the theta lies between minus pi by 6 and pi by 6. So I can write here theta belongs to minus pi by 6 to pi by 6 like this. What we do now, since theta is the difference between theta k1 minus theta k2, I can write that mod is always lesser than equal to pi by 6 because theta is the difference between theta k1 minus theta k2. I hope you understood this thing. Now theta k means what? Theta k1 means what? We are actually getting the argument of that complex number theta k1. It means it is achieved at k1. Let's say in this way what we can write is, because each theta is 2 k pi by 1997. So theta is 2 k pi by 1997 with k actually. So if I want to find the k1, I will get it here 2 k1 pi minus 2 k2 pi by 1997 mod, and that is pi by 6 as it is. You can notice that the pi I can take common and that will get cancelled. So what I'm getting is k1 minus k2 mod on the top, and this side I'm getting as 1997 by 12. And 1997 by 12 is what? Let's find it out. It's so 1 and 79, so 6, and again 77, so 6. So it's approx is actually getting equal to 166 point something, but since we are looking for this integer values, I can take that k1 minus k2. Two complex numbers are located 166 unit apart from each other. It means one you get at, let's say, located at 0, the other you will get at 166. It's like, suppose I'm substituting k1 is equal to 0, I will get k2 is 166 or minus 166. But if I take k1 is equal to 1, I will get k2 as 167 or minus 165. So it's basically the gap, whatever gap you are getting, how many such gaps you can get, that this possible values is actually minus 166 to 166. Except when these two will become equal, that is, I cannot take 0, because k1 minus k2, you can notice that can lie between minus 166 to 166. And for each of this, we can find some values of k1, k2, so that it will give you the exact position of the two complex number which is desired. Means the angle between them is differ by pi by 6, means less than pi by 6, differ by less than pi by 6 or equal to pi by 6. It means how many such pairs we can get for k1, k2, that is the how much total is minus 166 to 166 is 332 and 1 0 there, but 0 we cannot include because I cannot take k1 and k2, otherwise the two vectors will become same. Because if k1 is equal to k2 will become, so v and w will become the same vectors. But you notice that they are given that v and w be distinct randomly chosen vectors or roots of equation. So in this case, we cannot take k1 is equal to k2, although it lies in this interval. So k1 minus k2 can be only 332 choices, and these 32 choices, is actually we are choosing from 1996 choices. So in this way, whatever the result will come, that should be the answer. In other way to think that for each 1997 vertices, I have this much thing, because 1997 when I'm going, I'm doing this thing 332 by 2, because for each now 1997 I have half of 332, and we are dividing by, now we are choosing two vertices, so 1997 to C2. So if we calculate it, let's calculate, I hope it will get the same thing, 1997 into 332, what I've written here, my God, by 2, and this is going to be 1997 into 1996 by 2. So you can notice that this will cancel and we get the same value. So in this way we can do this question, whatever result you can calculate it, and that should be the answer. So that's much only for this video. See you in the next video with some other good questions and their solutions. In fact, I'm getting so many questions that I cannot cover up because of other works I have. So by the way, we have almost 25 days. So in those days, upcoming days, I'm going to cover. I don't care from where I'm selecting the questions, because sometimes I will select the questions from old GTA. That's why I'm not writing the GTA number. And even I don't know what the GTA number is. I'm just getting the questions and I'm just solving it. So it's just from any GTA and not only from Chaitanya. I'm planning to take some other interesting questions also. So we will see it. When time comes, I will try to cover every questions what I'm receiving. So see you in the next video. Stay math active.